All right, getting you ready for the probability test. There are so many different things that you need to know how to do. There's a lot of different ways to compute probabilities. I want to remind you about a few at the beginning here. You can use blanks. What are blanks good for? Blanks are good for things that can repeat. Let me give you an example. If you were going to do like people standing in a row of 4 people, you couldn't go like 4 times 4 times 4 times 4. That would imply a person could be in 4 different spots at the same time. Okay, so you can't do repeating with certain problems. So can you do repeating problems though? Yes, like license plates can repeat. You can have like 666 on a license plate, even though they actually throw that one out because a lot of people do not want that on their license plate. So, are you guys asking a question about math? Okay. All right. And there are some people that really don't like the number 13. There's actually a whole fear of the number 13 called triskaidekaphobia. That's the official name for it. And there's one guy that got so worked up about it that he was really smart, and he saw this date coming. And he actually, because the date had all these 13s in it, he didn't kill himself, but he worried himself to death. He actually died of fear. So anyway, there was actually, for a while, they were building buildings without the 13th floor and all kinds of stuff. So yeah, they'll have like 12th floor, and then they go to the 14th floor. So if you're really truly scared of the 13th floor, you just shouldn't be on which floor? The 14th floor, because it's really the 13th. Okay, anyway, so blanks are a good method. You put in little numbers and you multiply them. The next one is trees. You can make a tree like this. Sometimes we do that for works and breaks. Sometimes we do it for like, you got 2 choices and then after that you got 3 choices. Trees are really versatile. They will answer almost every possible question. Trees are really, really good for probability, but they can take a long time to draw. When you're thinking about drawing a really massive tree that's got 2 parts to each thing, binomial probability works. And binomial formula looks like this. C in front and then 2 sets of parentheses. Remember that one? Okay, so I want to do a binomial to start. You've got this kid, and he is a really good free throw shooter, 95% free throw shooter. Okay, and he gets 4 shots at the end of the game. And what happened was he got 3 out of 4 of them. It seems very realistic, but what was the probability of that happening? Set up one of these, use a calculator, and actually multiply it all out. Kid got 3 out of 4 of them. He did. He lived to tell about it. If you were Chinese, you'd probably be afraid of the number 4. You know, it's Chinese. Japanese might be afraid of a different number, but I know that Chinese don't like 4 because the word 4 is also the word for death, and it ends up basically being a really unlucky number. And in China, they have 8s as a very lucky number, and so they'll be really, really happy to use an 8 like in their license plate, or if they're buying a stock and its price has an 8 in it, that's like, ooh, that's a good sign. So, yep, kind of like in this country, 7 is kind of a lucky number. There are a lot of amazing 7s. You know there's 7 holes in your head? 7 holes in your head. Think about it. 7 holes in your head. 7 C's. 7 days in the week. There's lots of stuff. Anyway, let's move on. We have 4 shots. I'm going to make 3, and then the make percent's right here, and I'm going to put make. And then I'm going to put miss. You do not have to label those, but they just help you keep organized. And I got 3 makes, and that means I got 1 miss. The miss was 0.05. And you go 0.95 to the third, 0.05 to the 1. And this tells me how many paths there would be, so that's a number. And when you multiply it all out, Raise your hand if you have the answer. All right, Miss M. What did you get? 1715. Can anybody verify that? Yes. Yes. By the way, you looked it up? Oh, okay. So interesting. So it is Chinese and Japanese. Either way, they wouldn't like a 4 on their license. Okay, cool. All right. Power of the internet at your hands. Now this one, this 1715, that means there was only a 17% chance of that happening. What do you think was more likely that would have happened? Would have made all of them. Would you please figure out that one? Find the probability that he'd make all of them. All of them would be 4C4, and you don't, if you're smart enough, you don't need to type that into your calculator because it means what? 1. And then you got 0.95 to the 4, and then you got this 0.05 to the 0, which means you don't have to type that in either, right? Because that's just going to be 1. So you really just need to type that in. And what do you get? 8.145, which you round to 815. So there's about an 81% chance that kid's going to hit all 4 of them. Okay. Do you get how that's totally different, though, than the 95% chance? Because, see, some kids would have just said, well, he's got a 95% chance of making it, duh. No, not when you multiply it out times itself 4 times. So there's an 81% chance he'd make all 4 of them. Then there's a 17%. Do you get how there's a really low chance if you're really that good of a free throw shooter? It's a really low chance that you're going to make only none of them, so you're going to miss all of them. And if you think about that, it's 0.05 to the what? 4, because the other one will be 0.05. So 0.05 to the 4th would be an extremely low number. Would you please, somebody's got that, what is it? So 1, 2, 3, 4, 5 zeros, and then what? 6, 2, okay, good. Now, here's when you'd ever use that. When they say, what's the probability that you're going to make at least one of them? At least one means 1 or 2 or 3 or 4. And you could add all those up. Or, the smarter way, take 1 minus that. Now, if you want to do it the slower way, you can add up. At least one would mean 1 or 2 or 3 or 4, and ors mean add them together. Or you could take 1 minus that number, and you'd have 0.999994, which means there's basically a 99.99% chance you're going to make at least one. All right. That's one of the harder kinds, binomial. Let's talk about warranties. I want you to draw this one out as a little tree. Works and breaks. All right, so there's this projector, like we've got above in the classroom here, shining onto the smartboard. And projectors like that cost about $1,500. So let's say you've got a $1,500 projector. They sell a $100 plan that will protect it in case it breaks in the next 3 years, let's say. $1,500 projector, $100 warranty. And what else would you need to know? Yep, and I'm going to say there's a 5% chance of breaking. Would you please figure out for me the answer? Now, when you're doing these in the real world, the one thing that they will never tell you is they'll never tell you what the percent chance is that the thing's going to break. If they could just tell you that, you could do this simple calculation, and you could always figure out whether their warranty is priced fairly or not. You could look it up on the internet and see, but a lot of times if it's a newer product, they don't have the info yet until later. Yes, you can just kind of use your best guess and your best judgment. But if you instead were to think about past products that have been similar, like let's say they come out with the iPhone 5. Didn't you figure that probably the iPhone 4 is going to be related, like how many of those broke? It's going to be similar. Now, every now and then they have a fluke thing, like on the iPhone 4, the first version of it, it had an antenna that was kind of messed up. You could actually probably have considered that broken, in that if you held the phone, like a normal person holds the phone, the antenna was wrapped around the outside of the phone, and so it would make your call drop if you held the phone like a normal person holds it. And they fixed that. The antenna is still wrapped around the outside of the phone. It's this, we call it aluminum around the outside. But now they've changed the pieces around so that unless you happen to hold it like this, then you'll fry the phone and it'll drop the calls again. But unless you're touching it in like 6 weird spots, then it won't die. It's called the death grip. So anyway, now you'd say works and breaks, and I have told you a little way to remember this: P times A, then add them up. You always have to figure out the probability, then you times by the amount you're going to get if that happens, and then you add them all up. So what's the probability of it working? 95%. Breaking? 05. How much do you get if it works? Nothing. I think that's the easier way to do it. Some people say a negative number there, like negative $100 warranty, but which would you rather multiply by, 0 or negative 100? I'd rather multiply by 0, okay? Because it's just, when you multiply by 0, you get 0. And then the breaks part is 0.05 times how much do you get if it breaks? $100. And again, you don't have to make it complicated by, no, $1,000, sorry, $1,000, $1,500. Sorry, I forgot we were talking about that. What do you call that thing? The projector. Nope, not if you're doing it this way. My way is, I think, easier, because we will figure that in at the end. So we're just going to take 0.05 times 1,500, and who's got that number? 75? Then, that's the fair price of the warranty. See, if you do it that other way, you don't get the fair price of the warranty. That's the fair price of the warranty. Is that what you actually pay? No. So therefore, you could tell the difference is how much you're losing to the store. You're losing $25 on average. That's the expected value if you pay for the warranty. Now, could you have done it the other way? Yes. You could have subtracted, put a minus 100 here and a minus 100 here, but in my opinion, that's harder. And you never get the actual fair price of the warranty if you do it that way. I like seeing the price would have been fair at 75. Should I pay 100 for it? Well, that's actually not that bad. I'm only paying then a $25 premium for that peace of mind. So it might be worth it. Yes. The test on that problem will probably be multiple choice, and the answer either way is negative 25. I just think this way is easier to calculate. You don't have to like add these weird decimal numbers here. You're adding 0. And when you're multiplying by 0, that's always faster too. Okay, so it's your choice. Either way, the answer is negative 25. You're going to lose $25 if you buy that warranty. Does that mean everybody who buys a warranty loses $25? No. It means on average. Okay, let's talk about another kind of probability that comes up a lot. Venn diagrams is on today's homework near the beginning. We're going to make a quick Venn. I want you to think about this situation for yourself. This is your family having a cat. This is your family having, I suppose we could, but that's going to be more rare. I'm going to say, I just want to do things that aren't like, like rich versus poor kind of things. So, gators, yeah, that's going to be popular. Alpacas, great. I guess I could go with, well, dog is more common than cat. I'll just go with dog. And then the last one is something completely different. Let's say, how about this? Any other animal. And no, your brother does not count. Okay. So I want you to figure out which spot you would be in, and then when I ask, I'm going to ask for a show of hands, how many of you are in this spot, for instance? Just raise your hand if you're in that spot. Who's in this spot, right in there? 1, 2, 3, 4 of you. Who is in this spot between with a cat and a dog, but not any other animal? 2 people. All right. That's all right. That's all right. Is it for you? Were you in the cat, or are you in the cat and dog? Okay. All right. Let's move to the other one, which is just dog. No other animal, just a dog. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Is there anybody in that golden center place where you have a cat, a dog, and some other animal? First, cool. What is the other animal? Here. Ah, awesome. All right. And how about people that have a dog and some other animal? Curious, what is it? Okay. Seriously. 3, 4, 5. But there's 5 there. Okay, I got chinchillas, fish. What else you got? Fish. Who else had that situation? Hermit crab. Awesome. I saw one of those in St. John. It was huge and colorful and amazing. I took a picture of it, so you gotta ask me later. I'll show you. Yes. We got a rabbit. Cool. Ever think about eating it? People do eat them. It's like treated like a dog. Yeah. How about cat and any other animal? Anybody in this spot right in there? Cat and some other animal. All right, cats are kind of rare in the first place, so I'm not surprised there's 0 there. All right, and then how about you have some other animal and not a cat and dog? All right, what is the other animal? It's not an animal. It's not an animal. All right, so do you seriously, so how about this? I'm going to make this 0 then. Is there anybody that has none of the above? No cat, no dog, no any other animal. 1, 2. We're counting an animal as a fish as an animal. I know technically it's not, so I'll put you in here. Because now I'm doing any other animal, like you don't have anything. No living beings except humans at your house. 1, 2, 3, 4, 5, 6. All right, good. Now, here's my question. What's the probability, if I pick a random one of you, that I will get somebody with a dog? I will help you add them all up. 27. That is up to 27. Probability of me picking one of you, and I pick a person that has a dog. I'll double check my math here. 10, 20. Oh, it's 28. Sorry. Change your calculation. It's 28. 28 possible. All right. So then the dog, that adds up to 17. So it's just simply 17 out of 28. All right. Now here's the much harder kind. The givens. Given that they have a dog, what's the probability that they don't have any other animal? It's given that they have a dog. In other words, I'm only going to pick from dog people. What's the probability that they will not have any other animal? All right, here's the key to this. The given changes the denominator. Given that they have a dog means I can only pick from these numbers. If you ever use another number after that, you're doing it wrong. Okay? So then that adds up to 17. And that goes on the bottom because those are all the things that are possible. Now, not any other animal. It's really tempting to use some other numbers like this one or this one, but you can't. You have to stay inside the circle of life. So if they're given a dog, what's the probability that they don't have any other animal? Then these people wouldn't qualify because they have 2 things. These people wouldn't qualify because they have 3 things. These people wouldn't qualify because they have 2 things, a dog and something else. Then it really comes down to just those. So 9 out of 17. Raise your hand if you had that one right. Yeah, more than I expected. All right. Next, let's talk about P's versus C's. One of them, the order matters. One of them doesn't. Which one does the order matter? P. The order matters. All right. Now, I want you to tell me if there's 28 of us in here, and I was going to be able to pick 5 of you to go back down to St. John and spend another week studying underwater hermit crab formations, whatever. And I got some grant from the government, and they was going to pay for our tickets and everything. How many of you would enjoy going? Okay, yeah, I would too. I'd like to lead that one. Then, how many different groups could I take of 5 people out of this class? There's 28 of us. So are you using a P or a C? A C, because the order doesn't matter. You just either go or you don't go. So you got 28, C what? 5. All right, now, let's say that you want the group to contain you and your friend. What's the probability that that will happen? This is a much harder question, and I will encourage you to use blanks to figure out how many could go in this situation. The probability, we already got the bottom part of the probability, right? There's 5 people going. Those are all the possibles. How many are there that have you and your friend? And again, in a situation like that where you want to like change the numbers around dramatically, use blanks. You can say there's 5 spots on the trip, right? If you and your friend get to go, then it's only a 1 choice for this, 1 choice for that. That's what we're trying to get at. And then how many choices for the next 2 spots? There's actually 3 spots. 26, and then 25, and then that's how you do that. Does that make sense to you on the top and then the bottom, and then you divide them, and then you get your probability, and it's not a very high one because it's such a big number on the bottom. What did it come out to? Yeah. 15 point something, good. About 16% chance. Yeah. All right. And if you were to, I have a guy in our church that is a pilot. He's a commercial pilot, but he's like the kind where you hire him to do individual little jobs. He doesn't just do like he doesn't fly for an airline. So he actually has a plane. So he could actually, like, if his family wanted to come along and he was willing to fly, I'd probably be like, okay, we had 5 spots. This guy's willing to bring his family with the plane. We would lock in a spot because if he could fly us down there, that would be awesome. You have a private pilot fly you down. He's got a plane that holds like 16 people in it, so it's really cool to have somebody like that fly you down. All right. Anyway. Go to a different kind of problem. Let's go to cards. There's a lot of card questions. All right, 52 cards in a deck. Would you please, right now, shut your iPad and just use your calculator? And are you going to be focusing on the P or the C button? All right, that iPhone that is being operated right now, I see you. That comes up on my desk right now. Thank you. It's a no-no. I think you know that. All right, would you please figure out with your calculator, how many different 2-card hands are there? This is like for Texas Hold'em where you get dealt 2 cards. How many 2-card hands are there? And remember, when we do card questions, the order never matters. Yes, sir. That sounds familiar. Raise your hand if you agree with him. Excellent. That's pretty much everybody. So, next question is, if you've got a favorite hand. I knew a guy, and his favorite hand was the King 6. It was this weird thing. It was his favorite hand, and he swore he won on that hand very often, which is not a great hand. King and a 6. All right. How many different combinations? It could be any kind of king, and it could be any kind of six. How many different of those hands are there? So when this guy gets that hand, he's like, oh, I'm winning. True story. He's like a near professional level card player too. So those guys can actually take hands like that and then bet them in certain ways to have an increased chance of winning. Basically, bluffing. Okay, so how did you do that second part? If it's out of 1326, how did you do the top part? Or do you have a question about it? All right, 4 choices for king, 4 choices for 6. And I would agree with that. Another way to do it, that would be the same thing, would be with C's. How many kings are there in the deck? And you're choosing to get, and that's really going to equal 4. That's why. And then the other one, there's 4 sixes in the deck, and then you want one of them. So it's 4 times 4 makes 16. So 16 out of 1326. What'd you get? 0, 1, what? Okay. So there's about a 1% chance on any given hand that you're going to get that guy's favorite hand. I think it was called the Grizz. The Grizz, isn't it? His card playing name was Grizzly, and so that was his hand, the Grizz. I gotta look that up and see if that's right. But anyway, okay. Next one, 5-card hand this time. Don't even have to do the math on it. Just have to write the little formula out on your iPad again. Write out a formula for me for this one. I want to get 3 queens and 2 sixes. What's the probability that I will be dealt that hand? It's extremely low, and don't have to do the math on it. Just set it up. 3 queens, 2 sixes, 5-card hand. Okay, there's a person to your, we're going to do it this way. There's a person to your left or right, and these 2 rows are together, these 2 rows are together, and the far 2 rows are together. And since there isn't anybody, then just look at each other. So I want you to compare with the person next to you and see if you agree. Next to you, Jonathan, over here. Jonathan, this is the person next to you. There you go. Three queens, 2 sixes. Do you all agree it's fit to choose 5 on the bottom? All right. And then the little harder part is on top. There's 2 separate things. One's queens. I got 4 of them out there. I want 3 of them. And then I got, what's this other thing? 6s. And I have how many of them? 4, and I want what? 2 of them. So you multiply those together and put it over those. Raise your hand if you had that one right. Okay, good. Let me look. You are correct. I didn't get it done in time. I heard the alarm and didn't get it done. Okay, next kind. And I will get to that in a moment. Next kind is about doing pizza questions. All right, so there's 5 kinds of veggies, 2 kinds of meat. I want to know how many 2-topping pizzas you can make. Remember, I haven't said anything about has to be certain amounts of meat or certain amounts of veggies. Okay? 2 meat, 5 veggie. Is that what I started with? And then 2 topping. How many different pizzas are there that you could make? It doesn't say you have to be one of each. It just says how many 2-topping pizzas. This is not a probability, so I really don't want a giant fraction. The trick on this one is to notice that I don't need to separate these. I should put them together. And there's 7, and I'm choosing 2. Raise your hand if you had that one right. Good. Okay, now I'm going to change it. This time, you have 1 meat and 1 veggie. If you can pick 1 meat and 1 veggie, how many different pizzas? 2C1 times 5C1. Raise your hand if you had that one right. All right, you guys are pretty solid. So then, there's more, of course, but I don't want to try to teach you everything today. Your assignment is, there's a review assignment in there, and it's kind of longish, and so we're only going to do problems 1 through 7 for your homework for tonight. Tomorrow in class we'll do a little practice quiz on Schoology again. It doesn't exist in there yet, so don't worry about it. Don't go looking for it. You'll end up with an old quiz that I don't actually want you to use. And I'll post that tomorrow. So tonight, just do problems 1 through 7. Tomorrow, in class, we'll do practice quiz, and then your homework will be to finish that worksheet. All right, and now, please be smart about this. You've got a math teacher who totally knows how to do all these probabilities. And I've got time today. There won't be many people asking me questions. So if there's any of these you don't get your help today when people aren't desperate. Tomorrow they'll be more desperate, and there's only one, there'll only be 10 minutes of help time tomorrow. So you can always come in the morning if you want to and get extra help then too.